What is quantum superposition? Hello and welcome to our channel as we explore the fascinating world of quantum mechanics. Today's video will be focused on the concept of quantum superposition, a mind-bending phenomenon that has puzzled scientists and intrigued the general public alike. Quantum superposition is one of the most fascinating and mind-bending concepts of quantum mechanics. It involves the ability of a quantum system to exist in multiple states simultaneously, until it is observed or measured, at which point it collapses into a single state. This idea has profound implications for our understanding of reality, and has given rise to many of the most promising areas of research in physics today, like quantum computing and cryptography. In this article, we'll delve into the basics of quantum mechanics, define what quantum superposition is, explore its many applications and implications, and examine the challenges involved in studying it further and realizing its full potential. Introduction to quantum superposition. Quantum mechanics is a fascinating field that has revolutionized modern physics. One of the most intriguing concepts in quantum mechanics is quantum superposition. The idea that a particle can be in multiple states at the same time may seem counterintuitive, but it plays an essential role in our understanding of the universe. What is quantum superposition? Quantum superposition is the ability of a quantum system to exist in multiple states simultaneously. These states are described by a set of mathematical equations called wave functions. In simpler terms, it is like a particle existing in two or more places at once. Why is quantum superposition important? Quantum superposition is important because it opens up a whole new way of understanding the behavior of particles. It provides a more accurate description of how the universe works and has led to the development of new technologies like quantum computers and quantum cryptography. Understanding the basics of quantum mechanics. To understand quantum superposition, we need to first understand the basics of quantum mechanics. Classical versus quantum mechanics. Classical mechanics deals with the motion of macroscopic objects like cars or planets, whereas quantum mechanics deals with the behavior of subatomic particles. Classical mechanics is deterministic, meaning that you can predict exactly where an object will go based on its initial conditions. In contrast, quantum mechanics is probabilistic, meaning that you can only predict the probability of where a particle will go. Wave-particle duality. One of the fundamental principles of quantum mechanics is wave-particle duality. This means that particles can behave like waves and waves can behave like particles. This concept is essential to understanding quantum superposition because it allows particles to exist in multiple states at once. Uncertainty principle. The uncertainty principle states that the more precisely you measure one aspect of a particle, the less precisely you can measure another aspect. This principle is a consequence of wave-particle duality and is a crucial part of quantum mechanics. Definition and explanation of quantum superposition. Now that we have a basic understanding of quantum mechanics, let's dive deeper into quantum superposition. What is superposition in physics? Superposition is a general principle of quantum mechanics that describes the ability of a quantum system to exist in multiple states simultaneously. How does quantum superposition work? Quantum superposition works by assigning a wave function that describes the different states a particle can be in. These wave functions can be added together to create a composite wave function that describes all possible states of the system. Types of quantum superposition. There are many types of quantum superposition, including coherent and incoherent superposition. Coherent superposition occurs when the wave functions of the system are in phase, while incoherent superposition occurs when the wave functions are out of phase. Examples of quantum superposition in real life. Quantum superposition may seem like a concept only relevant to theoretical physics, but it has real-world applications. Quantum entanglement. Quantum entanglement is a phenomenon that occurs when two particles are connected in such a way that the state of one particle determines the state of the other, no matter how far apart they are. This is a consequence of quantum superposition and has exciting implications for quantum computing and cryptography. Quantum tunneling. Quantum tunneling is a process where a particle can pass through a barrier that it classically shouldn't be able to. This is possible because of quantum superposition and has applications in nanotechnology and electronics. Quantum cryptography. Quantum cryptography is a secure method of communication that relies on the principles of quantum superposition. This method of cryptography is unhackable because any attempt to intercept the message would change the quantum state of the system, making it instantly detectable. The controversial implications of quantum superposition. Quantum superposition is one of the most mysterious and mind-bending concepts of quantum theory. It states that a particle can exist in multiple states or locations at the same time. This idea challenges our everyday intuitions about the world, as we are accustomed to thinking in terms of classical physics, where things have definite properties and exist in specific places. Schrödinger's cat. One famous thought experiment that illustrates the idea of superposition is Schrödinger's cat. In this scenario, a cat is placed in a sealed box with a radioactive source and a Geiger counter. If the Geiger counter detects radiation, it triggers a mechanism that releases a poison and kills the cat. However, according to quantum superposition, until the box is opened and observed, the cat is both alive and dead simultaneously. Many worlds interpretation. Another interpretation of quantum superposition is the many worlds interpretation. According to this theory, rather than collapsing into a single state upon measurement, all possible outcomes of a quantum event occur in separate branches of reality. This leads to the conclusion that there are an infinite number of parallel universes, each containing a different version of reality. Observer effect. Finally, the observer effect is another consequence of quantum superposition. It states that the act of observing or measuring a quantum object affects its behavior and properties. This means that the mere act of observing can change the outcome of an experiment, and it has profound implications for our understanding of the nature of reality. The role of quantum superposition in quantum computing. Quantum superposition is also central to the field of quantum computing, which aims to harness the power of superposition to perform computations that are beyond the reach of classical computers. Quantum gates and circuits. In quantum computing, superposition is used to encode information in qubits, which can represent multiple states simultaneously. Quantum gates and circuits are then used to manipulate these qubits, allowing for complex computations to be performed in parallel. Quantum algorithms. Quantum algorithms, such as Shor's algorithm for factoring large numbers, take advantage of quantum superposition to solve problems that would take classical computers an impractically long time. This has exciting implications for cryptography, drug discovery, and other fields. Current and future applications of quantum computing. While quantum computing is still in its infancy, there are already promising applications in fields such as finance, logistics, and materials science. As the technology advances, we can expect quantum computers to revolutionize industries and solve problems that were previously thought to be unsolvable. Challenges and limitations in quantum superposition research. Despite its potential, there are also significant challenges and limitations that must be overcome in quantum superposition research. Decoherence. One major obstacle is decoherence, which is the loss of quantum coherence due to environmental factors such as temperature and noise. Decoherence can cause the superposition to collapse, making it difficult to maintain the delicate superposition required for quantum computations. Experimental limitations. Another challenge is the difficulty of performing precise measurements and manipulations on quantum objects. This requires highly specialized equipment and techniques that are still being developed. Technological advancements needed for further research. The development of more powerful and stable quantum computers will require significant technological advancements in areas such as cooling, materials science, and software development. These challenges must be overcome before we can fully realize the potential of quantum computing and quantum superposition. Future applications and potential discoveries in quantum superposition. Despite these challenges, the potential applications and discoveries in quantum superposition are immense and exciting. Quantum teleportation. One potential application is quantum teleportation, which involves the transfer of quantum information from one location to another without physically moving the information itself. This has exciting implications for secure communication and data storage. Quantum sensors. Quantum superposition could also be used to develop highly sensitive sensors for detecting gravitational waves, magnetic fields, and other phenomena. Quantum gravity. Finally, quantum superposition may hold the key to solving one of the greatest mysteries in physics, the unification of gravity with the other fundamental forces. The development of a theory of quantum gravity would have profound implications for our understanding of the universe and the nature of reality. Quantum superposition is a fascinating and complex topic that has captured the imaginations of scientists and non-scientists alike. While there is still much we don't understand about it, the potential applications and implications are vast and exciting. As research and technology continue to advance, we may yet unlock even more secrets of the quantum world and harness its power for practical use. In conclusion, there is no denying that the concept of quantum superposition is one of the most fascinating and misunderstood topics in modern physics. Although it seems bizarre and unphysical, it's at the heart of the microscopic world and responsible for some of the most intriguing phenomena that make quantum mechanics so fascinating. As we continue to study the behavior of particles in superposition, we will continue to unlock the secrets of the universe and redefine our understanding of reality. Until then, we can marvel at the strange and wonderful behavior of particles in the quantum world and appreciate the immense contributions that quantum mechanics has made to our understanding of physics at its most fundamental level. Thank you for joining with us this informative video, and remember to subscribe to our channel for more fascinating content about the wonders of the universe. Thanks for watching.